So we are still talking about systems. We're going to talk about is a couple of strange results that we might be able to get. Look at that nice handwriting. Strange results. So my first system, 2x plus 6y equals 8, x plus 3y equals 8. I'm trying to find the xy pair that makes both these true at the same time. So I think what I'll do on this one is a little bit of elimination. I notice this is a 2x. If this was a negative 2x, those would cancel when I add them together. So I'm going to multiply this whole thing, this second equation, by negative 2 times negative 2. So the top equation is going to stay as it is. I'll rewrite it down here. 2x plus 6y equals 8. Multiply this one by negative 2, both sides. So I get negative 2x minus 6y equals negative 16. Add them together. X's drop out just like I wanted. But notice the y's drop out as well. So I get 0 equals 8 plus negative 16 is negative 8. 0 equals negative 8. So that should raise a little alarm for you, because that's not true. We know that's not true. So what this means is there's something wrong with our original statement, with our original premise here. In other words, like we started with a statement, we went through an argument, and we ended up with a conclusion that is plainly false. It does not work. So that means either there's something wrong with our argument, which there's not, all our algebra was sound, or there has to be something wrong with the original statement, which there is. The original statement will never work. There is no XY pair that you can plug into here and plug into here and make them both true at the same time. So if you argue something out, all the variables go and you end up with a false statement, that means there's no solution. Okay, so on to the next strange result. Same sort of thing. X and Y. I'm going to do elimination. I notice that this is a negative 3y and that's a positive 6y. So if this was a negative 6y, y's would cancel. So I'm going to multiply this top one by 2. I'm multiplying that entire top equation by 2. So if I do that, I get 2x minus 6y equals 8. And then second equation I wasn't going to touch, negative 2x plus 6y equals negative 8. Add them together. Y's go away like I thought they would. Oh, x's go as well, so I end up with 0 on this side. 8 minus 8 is 0. So notice this is like the last one in the sense that x's and y's dropped out. But 0 equals 0, yeah. I mean, no doubt. It's trivial. We know that. This is a statement that's always true. So if this is always true, same thing as before. We started with a premise, went through an argument, ended with something that's always true. That means that this has to always be true. What this means is that any XY pair that works here will work here. Think of these graphs, they're straight lines. We can say the same line. In other words, anything that works here works there. So anytime you end up with a false statement, no solution. Anytime you end up with a true statement, they're the same line.